Hello to vintage amateurs everywhere. This is a Heathkit DX-20, but as you can see, it isn't quite the same. The front switch has been changed, the meter has been changed, and pilot light has been added. But wait, there's more. In the back, there has been a VFO PL259 VFO input. But wait, there's more. Inside, a heavy-duty transformer has been substituted for the original weak Heathkit transformer, plus the tube rectifier has been removed and the solid-state rectifier has been changed. But wait, there's more. The old horizontal output tube that was used, that was kind of weak, has been replaced by a 6146. But wait, we're going to see how it works. But before we do that, I want you to know I am not going to charge you a mint for this. But if you remember to ask, I will include a mint with the DX-20. So let's see how it works. First we'll put in the driver stage, which is a 6CL6, and we will see what happens. Well, look, we can hear a little bit of something. But the light bulb doesn't light. Remember, that light bulb is quite illegal now. They don't sell them anymore, incandescent bulbs, so they're very, very rare. And some hams call it a dummy load, but I use it by its actual name, called a contester load, because contester and dummy are pretty much the same thing, as you all know. So now let's put it in the operate position. But wait, there's no signal. But there's a reason there's no signal. Look, we have a key. Now that comes from the day when ham radio used to actually have a skill involved in becoming licensed. You had to learn something that wasn't in a book of questions and answers that were all published. Test questions and answers all being published. You had to actually have a skill. And that skill wasn't all that difficult because my daughter had it when she passed her exam when she was 8 years old. Anyway, so we're going to key it up, and you can see we have quite a bit of output. I'm just going to peek it up there. Okay, that's the drive over there, and we had a little more, and we seem to get quite a bit of output here. So that works out pretty good. And if you look, I don't know if you can see the meter up top, it's probably out of the screen, but it indicates power in excess of 100 watts, which is clearly false, but it does indicate quite a bit of power. Now we're going to try another crystal. This one's slightly out of the amateur band. I don't know if you can read it, and that probably doesn't help you at all. But it says 6900, but it's actually even a little off. And I'm going to put another crystal in it and see how it works. And we have to move this up to 40 meters. Now when I say 40 meters, for those of you that are no-code hams, that does not mean that there are 40 meters included in this. No sir, not at all. There's just this 1 meter. And but the frequency it operates is 40 meters, which is about 120 feet or so. So if you're going to build a dipole, which I realize you no-code hams would not know what that is, but that's an antenna with two sides to it. Dipole. Anyway, let's put it in the operate position and see what we get. Okay, and I'm going to peek that up. Okay, and that's in the tune position. Now we're going to I'm going to move this over to here, and we're going to key it in the operate position, and we have, look, there's no output. But wait, there's more. You have to dip the final. We don't take the tube. We don't take the tube and put it. We don't take the tube and put it in kind of something like a cheese dip. This is the other type of tube that was originally in it. It's a BQ6, which has been replaced by a 6146. We don't take this and dip it in cheese. No, that would be a bad idea. What we do is we resonate the tank circuit. Now, when I say we resonate the tank circuit, there's not a there's not a tank, hardly, although you wouldn't call that a tank, but it's a capacitor and a resistor. A capacitor and a resistor, and I think I've got one of those. This is a capacitor, by the way, though the capacitor that they use is a little bit different. It's a variable capacitor with fins, not fins taken from a fish. I want you to understand, not fins taken from a fish, but a different type of fin. Anyway, we have it in the operate position, and let's dip the final. Whoa! See what happens when you dip the final? When you stick that final in the cheese, you stick that final in the cheese, it goes up. Okay, that's how that works. But we can increase the power even a little more. So we increase it a little more, and there we are. So we see that it operates on 40 and 80 meters. I'm not going to test it on any other bands because the crystal I have kind of works out. It doesn't really work that well out of other bands. But we'll try it anyway. Okay, so we've got it in 20 meters. Let's peak the final. That's not going to work out so good. Let's take that off. We'll peak the final. Wrong thing. There we go. There we go. That's peaked. And now let's see what we have. Put it in operate. And we'll dip the final. And increase it. And dip it some more. This is up on 20 meters. And so there we are on 20 meters. This is a DX-20 with the original tube that's inside of it. Of course, this isn't the tube. The actual tube is inside of it. And this one is a little bit. It has CW and phone pasted on the front, and there's a connector in the back. But I believe that the only reason this has CW and phone in it is that the connector is just a normally closed, normally open type connector when you throw the switch, and it's used probably to activate an external modulator, which did not come. So I believe no real modification has taken place for this to be CW or phone. So that ought not to be a concern. So it is pretty much original, as you can see. So let's see if it operates. And that's saying we have about 2 mils of grid current. They say we should have about 2, and that's about what we have. I have an 80 meter crystal in there. And now I'm going to put it in the operate position, and we'll see what we have. And there we go. We have a nice amount of output there. Let me put this in the plate position. And I believe the plate, this current is not indicating properly, because if you do a volt times amps, it's showing 25 mils, and that would be 12 watts of input, which would only give us 7 watts of output. But as you can see, the bulb is certainly lit a lot more than that. So the meter, the resistor that calibrates the meter in that position may be a little bit off. But you can see it pretty much operates normally. It pretty much operates normally, and that's on 80 meters. We'll try a 40 meter crystal, and let's get that in there. Okay, and we need to put this over to 40 meters. Put that in the grid position and see what we have. And I shouldn't have left that in that position. So we've got 2 mils of grid current, and there we are. And let's put this in the plate position now, and we'll tune it up on 40 meters. Oh, we should put that in that position. That will work a lot better. And we'll dip the final and see if we increase that anymore. Okay. And there we are on 40 meters. So I'm just gonna see if we can pick that up anymore, and that's about it. And I'm not going to test it anymore on any other band. I do have one other DX-20, and this one has some issues with it. For example, it has no case, and that would be a big problem. It does have a modification on the front, as you can see, a switch that says VFO or crystal, and it also has the filament in the transformer is bad. Naughty, naughty, naughty. It's bad. So that's going to be a problem, and it's also missing a 6CL6, although I certainly could give you one if you wanted to pay for it. So this one has some issue. This one has an issue in that respect. Replacing the filament transformer and adding the 6CL6, this very well might work. But I don't have a filament transformer with me, and we'll just take a closer look at it. And there it is. And let's turn it upside down, and you can see there's where the filament wire would go. It's right there, and it's bad, and it's bad. So you can see the rest of it looks okay. There is a connector coming out of it, and I have no idea what that's for. Okay, I did find a source for 6.3 volts for filament voltage, and I figured I'd hook it up and see how it worked. So it does seem to work. That's a DX-60 transformer, but I just tapped the filaments to run this because the filament windings on here were no good. And as you can hear, it does seem to have, if I go over to the grid current position, we do have grid current, and then now we'll put it in the final position. I have an 80 meter crystal in there, and let me flip this over to plate, and as you can see, it does light the dummy load, so it does seem to work. It's in the, I don't know if you flip this in the, you flip that in the crystal to VFO position. So even though this doesn't have a case, it does seem to work. I want to lower the drive there a little bit. It's a little high. It does seem to be a little high. Okay, but it does seem to work. So keep that and figure that out for yourself. So you do have it does need a filament transformer, and you don't want to use a setup like this because I dare not breathe on it. I tried it on 40 meters, and that's the crystal frequency, by the way. I tried it on 40 meters, and you can see, let's put it in the grid position, and you can see I have plenty of grid current. Put it in the plate position, and you can see the light bulb does light. So it does tune up. So it looks like it's going to work. I'm not going to include the 6CL6 tube